I start recording.
Okay.
Okay, right. Then
Okay,
I
sir.
share the screen. Where is it? Wait, Okay. Now we start with this one. Share. Okay, right.
Okay, sir.
This is the first application of differentiation. Okay, right. Take for example, we have a curve here. The blue line shows a curve. And I have selected 2 points on the curve, A and B. A and B, they are very close to each other. Only a difference of delta x and delta y. Okay. These two points, I join them using a red line. Now this red line is a chord AB because it cuts across the curve, this blue curve. So this red line AB is a chord. Okay, right. Now I'm going to drag this point B and make it approaches the point A. Can you see what I'm doing or not? Yes or no?
Yes, sir.
Yes. So
Yes, sir.
as I move the point B nearer and nearer to A, the value of delta x and delta y will decrease. Can you see on the screen here, this part? The delta y and delta x is decreasing. Okay, delta y is 0.96, delta x is 0.65. I keep moving this point B along the curve towards A. Now, when this point B is near enough to A, now can you see? Line.
Yes, sir.
Is this red line a chord to this tangent, to this blue curve? It now looks more like a tangent to the curve. So as we move this point B nearer and nearer to A, this red line becomes a tangent. Okay or not?
Okay. Okay, sir.
Right. So now, so at first we have this. Can you see this one I captured earlier? At first,
Yes, sir.
A and B, they are quite far apart. Okay. Finally, when the delta x and delta y is small enough, then this red line becomes a tangent. It is a tangent to the blue curve at the point A. Okay, and the gradient I have calculated, it is here 0.87. The nearer this point, the nearer this point B move towards A, okay, the nearer it is, the more it will be like a tangent to the curve, right? So you see, okay. Now as delta x approaches 0, delta y over delta x approaches dy dx. So what is dy dx? Dy dx we have learned earlier using the what? The first principle. Can you still remember the first principle? Dy dx is actually the limit of delta y over x as delta x approaches 0. Now that is mathematically, but physically, dy dx, it means gradient of the tangent at the point xy. Now in this case, now it is very near and the gradient is 0.68. So probably we can say that the gradient of the line is 0.68, the gradient of tangent at the point A. Okay, right. So can I move on or you have any questions to ask?
No, sir.
No, no question. No. Others?
No question. No.
Who are the others? Let me see. Participant, 5 of them. Young Wan Lee, any question? No. Megan? No. Karen? No. Ruby? No. Atira, no. Then, of course, I got no questions. Okay, right, next one. Okay, next one. Okay, the next thing, how to apply this thing. dy dx is the gradient of tangent at the point xy. How to apply this? Okay, we know that dy dx is the gradient of tangent, right? So we look at one example. So this example I've given you in your, how to say, this example I've given in your assignment 2. Can you remember assignment 2?
Oh,
Yeah.
yes,
So,
the Google Classroom.
yeah, in the Google Classroom, right?
Yeah.
If you cannot, then
Yeah.
we shift to this screen. Where is the screen? Oh, okay, this one. Move to this screen here. Okay. Okay. This is the Google Classroom. Can you see the Google Classroom now?
Yes, sir. Yes, sir.
Okay. So Google Classroom, we move on to classwork, right? Classwork. And the questions, they are all here.
The top one.
The top one. The top
Yes,
one
the
is the
top
simpler one. The second one is the more difficult one. The bottom one is the more difficult one. So there, you can see these questions. Only two or three girls, they have answered. Three, I think. Trisha, Yang Wan Li, and Li Lu Ying, they have submitted the answers. Li Lu Ying answer is correct except one question. So I've checked the answers already. So this is our assignment, remember, right? So now try to switch back to the questions. I'm going through the questions with you. Okay. Okay, right. So first one. Okay, first one. How to apply dy dx as the gradient of tangent? How to apply? Okay, first one. Okay, the first example is this one. X squared plus 3x minus 4 at the point 1, 0. Okay. So what they are asking us to do is, please, they say lah, in my own words, so please find the gradient to this curve at the point 1, 0. Understand the question or not?
Yes, sir.
Yes, understand.
Yes, sir. Yes.
If you don't understand, you can always ask question. You put up your hand. In this box there, I can see your hand one, There's an icon, the hand icon there. Okay, you can.
Yes, sir.
You can see. Can you see this box or not? This box.
Which box?
Or you cannot. You just see the screen only. The geometer sketch.
Yeah. Yes, sir, there's an option more. You press that.
Then you can see the many names there. So yes, I can see Megan's hand already. Okay, I can see. So you just do like Megan. You have any questions? You just put out. I also put up the hand. Megan also put up the hand. Okay. So you just raise your hand if you have any question. Okay or not? Let me print screen first. Okay, right. So now, where are we now? Okay, right. We are supposed to find the gradient of tangent to this curve, x squared plus 3x minus 4 at the point x1, y0. Okay, so that is our question. So I start off by finding dy dx. Why I must find dy dx? Now you look at the top left-hand corner.
Because it's the gradient, right?
Because dy dx is the gradient. That's why I want to find dy dx. If I can find dy dx, then I can find the gradient. Okay, so I start off by finding dy dx. Can you still remember how to find dy dx? Can you still remember how to find?
Yes. Yes, sir. Differentiation.
Differentiation.
Yeah.
Okay, so after finding this dy dx, you note that this dy dx has a term involving x. They cannot give me the gradient. Why? Because this dy dx is a variable. It depends on the value of x. Okay or not? So by substituting different values of x, I will get different gradient. This means that at different points along the curve, the gradient will be different. So far, okay or not? If not, then you can become like what's the name that
Okay,
girl?
sir.
Always disturb one in the class. Okay, right. So dy dx, then after you find dy dx, dy dx is a general value. It has a term involving x. Only when you substitute in one value of x, then the answer will be a number, right? So this shows that the gradient depends on the value of x. At different points along the curve, they will give different tangent, different value of tangent, gradient of tangent. So in this case, if I want to find the gradient of tangent at the point 1, 0, I have to substitute x equals to 1. Okay. So only after you have substituted numbers into the dy dx, then you will get a numerical value for the gradient. So far, okay or not? So if I want to find tangent
Okay, sir.
at the, okay, I want to find tangent at the point x equal to 1, so I have to substitute x equal to 1 into dy dx. Okay, so here I get it. Gradient of tangent at the point is 1, 0 is 5. Okay, next one. Okay, this is the first question. Another question, this is part A. The question is up here. How many of us now? 2, 4, 5, 5. Okay, including myself, 6. Okay, so the first question, I have a curve y equals to 2x squared plus 6x minus 5. Minus 5. So this is the curve. I want to find the gradient of tangent to this curve at the point x equals to 1. They have to tell you at which point, because if they don't tell you the point, then you cannot find a specific value for the gradient, because different points, they have different gradients. Okay, right. So we start off by doing what? What is the next step? Anyone suggest to me? What is the next step? Find what?
Find dy dx.
Correct.
dx.
Correct. Find dy dx. So I differentiate, and I get dy dx is 4x
X
Plus 6.
4x plus 6. Okay. So what must I do after finding dy dx? I have to substitute.
Substitute the x value.
to
Substitute the
the
x
point.
to the
Correct. Okay. In this case, what is the value of x that I have to substitute?
1.
1. The question A, I have to substitute 1.
1.
Okay. So I substitute 1, then I get the answer. The dy dx is 10.
And
The dy dx is 10. It means that the gradient of tangent at this point is 10. Now, we come to the next two questions. Now, these two questions, they are, how to say, they are the same, but the way you differentiate is different. One, you need to use the product rule, and the other one, you need to use the quotient rule. Can you still remember the product rule and quotient rule?
Yes, sir.
Yes. Okay. So I ask you, part B, what rule you use?
Product rule.
Yes, product rule. So part B, I have to differentiate y with respect to x using the product rule. I'm going to explain to you how to use product rule again. How to use product rule again. Okay. Can you see the two brackets here? Now,
Yes, sir.
in order to use the product rule, you have to differentiate the first bracket, then keep the second bracket. After that, you
Plus.
keep the first one, differentiate the second bracket.
Second.
Okay, so is that Is this what you will get? Yes or no?
Yes, sir.
So the first one, you differentiate 2x plus 1, you get 2. Then this x squared minus 3, you just keep it. Plus, now you just keep this, and you differentiate x squared minus 3, you get 2x. Okay, so it's simple as that. Now, after differentiating, I have to substitute a particular value. In this case, the value of x is negative
-1.
negative
1.
So I try to get, okay. So substituting x equals to -1. X squared become positive 1. No? Negative 1 multiplied by 2 is negative 2. So finally, dy dx is -2. And what can we say? The
The
gradient
gradient of tangent.
at the point negative
-1
2
to
is -2.
is
Okay.
-2.
So far, can you follow? Now,
Yes, sir.
okay. Now, what we need to make use of, I have written in blue color at the top left-hand corner. Can you see this top left-hand corner here? Yeah.
Yes, sir.
Okay. So we are going to make use of this to find to solve the problems on this page. Question C, you want me to go through a quotient rule with you? Yes or no? Revise quotient rule? Okay,
Yes, sir.
we revise quotient rule. Okay.
Yes.
Quotient rule. The quotient rule is, I think a lot of participants are hiding their face. Only one. Okay, never mind. Okay. Quotient rule. Quotient rule. Let me. Oh dear. Off this one. Right. We look at question C. Question C. We have the numerator 5x minus 2. The denominator is x squared.
X square.
The point is 2, 2.
2.
Okay, right. So if I want to differentiate this function y with respect to x, of course, we break it into two parts. The top part, or the numerator, the bottom part, or the denominator. So what must I do first? Okay, right. Now,
Differentiate up.
first, you have to differentiate the
Differentiate numerator.
numerator. Differentiate numerator, you get the x here. Can you see the arrow that I'm pointing? The mouse
Yes,
arrow?
sir. Oh, yes,
5. Then I keep the bottom, the denominator. Okay, that's
Yes,
how I get
sir.
the x squared. Minus, just now I've differentiated this. So now I keep the top. Then I differentiate the bottom, the denominator. When I differentiate the denominator, I get 2x. So can you understand how to get this thing here?
Yes, sir.
Then you have to divide by the denominator square. The denominator square. So of course, this look very ugly. You have to simplify. So how to simplify this? You expand. Okay, you expand and gather the terms together. Finally, the dy dx is negative 5x squared plus 4x divided by x to the power 4. And substitute x with what? Substitute x with 2. Correct. Substitute x with 2. And finally, the gradient of tangent at the point 2, 2 is negative 3 over 4.
3 over 4.
Okay. Right. So we look at the next type of question on the next page. Now, if you look at the top left-hand corner, top left-hand corner, how many colors are there? Can you tell me?
Three colors.
3 colors. Each
Three.
color,
3 colors.
yes, each color represent something that you need to know. So the first one, blue color, is you need to know the dy dx
Gradient.
gradient of tangent. That's the first thing you need to know.
Okay.
Okay, the second one, the purple color, you must know the formula for the equation of the straight line. Y minus y1 equals to mx minus x1. Okay, and the last one, the green line, the green words. The two gradients, if they are perpendicular, then the relationship between the two gradients are m2 equals to negative 1 over m1.
1
You just,
M1.
yes, you just inverse the gradient, find the reciprocal of the gradient, then you change the sign. Remember or not? When we did coordinate,
Yes, sir.
Yes, sir.
we start. Okay. The question is like this. Find the equations of tangent and normal to each of the following curves at a specific point. Okay, this one, the first one is an example. Y equals to x squared minus 4x plus 5 at the point 1, 2. Okay. What they want you to do? They want you to find the equation of tangent and equation of normal to this curve at the point 1, 2. Is that okay?
Yes, sir. Okay.
So,
Yes, sir.
as usual, we just differentiate. Anyway, this is a topic involving differentiation. Whether you know how to do or you don't know how to do, you just see the equation, you differentiate, find dy dx. So very simple. If you want to find dy dx, right? So dy dx is 2x minus 4, and you have to substitute in the point x equals to 1. So you have found out the gradient to be negative 2.
Negative 2.
We call this gradient m1. Why we need to call it m1? Because we
Because
want,
for normal,
because later on we need to find the gradient of
reciprocal,
normal.
Yeah.
Normal. So when we want to find normal, you call that m2. The gradient of tangent, we call it m1. Is that okay? One more time.
Yes,
okay,
sir.
sir.
One more time. I find the gradient of tangent dy dx is negative 2. And I call this tangent, gradient of tangent, m1. So, and the given point is 1, 2. The point is 1, 2. So making use of the gradient and the point, we can find the equation of the straight line using this formula. Y minus y1 equal to mx minus x1. So substituting the gradient and the point into this equation here, we will get the equation of tangent. So far, can follow or not?
Yes.
Yes, sir.
Okay,
Yes, sir.
continue. If cannot, then you just put up your hand. Yeah, manage the participant. Ready? Nobody put up hand already. Just now, Ayn put up the hand. Ayn, are you still with us? Ayn, don't know. Okay, never mind. Now we proceed to find the equation of normal. Now to find the equation of normal, we use this formula, y minus y1, mx minus x1. Okay. Time's up already, they say. 40 minutes only, we are even free. Okay, I quickly go through this. Okay, so
Okay, sir.
we try, not yet, they will tell us when it's time. So I try to find the gradient of normal. Okay, the gradient of normal is what? You just use the gradient of tangent You find the reciprocal, and this will be the gradient of normal. You just inverse the tangent and change the sign, you will get the gradient of normal. Using the gradient of normal and the given point, you substitute into this formula and you will get the equation of normal.
Okay, sir.
Okay, huh? So can stop the how to
So no
stop.
need to make the 2y become y.
Make sure there's no denominator lah. If you want denominator, then you use y equals to mx plus c.
So if I put my final answer as y equals to 1 over 2x plus 3 over 2 means?
Can.
Okay.
Okay, so now video. Okay, what are we doing now? Okay, how to stop? Okay, can you still see me?
Yes, sir.
Yes, sir.
Yes. Oh, I just stopped the other one, the sharing the whiteboard. Okay, so that's all. If you have any question, you ask now. If no, then we just dismiss. You can end the
Okay,
meeting.
thank you so much, sir.
Thank you so much, sir.
Thank
Okay,
you, sir.
welcome. See you again
you,
at
sir.
1:45.
Sir,
Huh?
sir,
Yes.
sir. Are we still having the meeting at 1:45 p.m.?
I will have 1:45 because I have informed the others 1:45. So I will come back again. I repeat the same thing. So if you have listened,
Okay,
then
sir.
it's okay. So
Okay, sir.
can I leave the meeting now?
Okay.
Okay.
Yes.